The outbreak of the Korean War brought a massive surge in funding to American defense contractors. Lockheed secured a major order to build a new version of the Neptune. This would become the most widely produced variant of the aircraft. It was the P-2V5. It made its maiden flight on December 29, 1950. The new version retained the nose section of its predecessor. However, the armament received a major upgrade. Replacing the older 50 cal machine guns, engineers installed a modern fire control system. This system was linked to twin 20mm cannons in a redesigned defensive nose turret. Additionally, the aircraft gained the capability to lay naval mines. In 1952, the design of the aircraft underwent a significant update. The tail section of the fuselage was extended by nearly 17 feet. This was done to house a specialized piece of equipment. It was the ASQ-10 magnetic anomaly detector, also known as the MAD boom. This was a major technological breakthrough. The device made it possible to detect, identify, and continuously track submerged submarines. Operating on a highly sensitive principle, it picked up minute anomalies in the Earth's magnetic field. These were caused by the steel hull of an enemy sub. Over time, the avionics received further upgrades. The original radar was replaced by the significantly more powerful APS-20C system. The targeting radar was relocated to the tail compartment. This left only a high-intensity searchlight for night missions, which was housed in the right wingtip fuel tank. The crew complement was also updated with the addition of a tactical coordinator, or TACO. This specialist became a crucial asset in hunting and prosecuting targets. All vital sensor telemetry flowed directly to his station. He analyzed this data in real time and relayed it to the pilots. This allowed them to quickly assess the tactical situation and authorize weapons release. Adding this new crew station and replacing the electric elevator controls with a hydraulic system increased the overall gross weight of the aircraft. To offset this weight penalty and maintain the desired flight characteristics, engineers had to make a compromise. The capacity of the wingtip fuel tanks was reduced from 350 to 200 gallons. In total, 424 of these Dash 5 variants were built. This variant became the backbone of maritime patrol aviation across the globe, entering service with numerous allied nations. The final P-2V5 rolled off the assembly line in early 1954. Meanwhile, in the mid-1950s, the Soviet Union launched an unprecedented submarine building program. Their annual production rate reached 74 units. This meant the Soviet Navy was commissioning a brand new submarine every 5 days. These were primarily Project 613 medium submarines. They were known to the West as the Whiskey class. Compared to previous generations, they featured significantly improved underwater maneuverability. They also had double the diving depth and far more advanced electronics and weaponry. By 1962, Soviet shipyards had churned out 215 of these boats. To counter this rapidly growing submarine fleet, the United States had to act quickly. They implemented a multifaceted approach. This included rapid technical upgrades to drastically improve the performance of their own patrol squadrons. The engineers at Lockheed tackled these technical challenges head-on. Taking a cue from their competitors who were using mixed power setups on the Mercator, they decided to give the Neptune a major upgrade. They bolted on 2 additional Westinghouse turbojet engines. Each of these put out 3,250 pounds of thrust. These new jet engines were mounted on special pylons under the wings. They were positioned just outboard of the main radial engines. Adding these jets was a massive game-changer. With the extra dash speed, the aircraft could now sprint to a suspected submarine contact much faster. They designated this modernized version the P-2V5F. From then on, jet engines became standard across all subsequent models. They even started retrofitting them onto earlier P-2V5s. Beyond the extra speed, the jet pods dramatically improved takeoff performance. This extra capacity allowed engineers to equip the Neptunes with 2 cutting-edge sonobuoy systems. The passive Jezebel system acted as a giant ear, listening for the acoustic signatures of propellers and machinery. Meanwhile, the active Julie system worked by actively bouncing sonar pings off submerged hulls to pinpoint their exact location. The Neptune's platform proved incredibly versatile. Standard airframes were frequently modified for highly specific missions. Some were converted to air launch and remotely control supersonic target drones for fleet weapons training, painted in vibrant high-visibility colors. Others were packed with specialized electronics for deep electronic intelligence gathering. The military quickly realized that their success using hydrophones and sonobuoys to hunt submarines could be applied in other ways. This paved the way for Neptunes to be deployed during the Vietnam War to drop sophisticated acoustic sensors. These small devices helped U.S. forces covertly track the movements of enemy troops and equipment through the dense jungle canopy. In 1967, General Dynamics heavily modified 12 P-2 V-5F aircraft. These received the new designation OP-2E. The old search gear and extra fuel tanks were completely stripped out. Instead, they packed the aircraft with dispensers for acoustic sensors. They also added what were then state-of-the-art television and reconnaissance cameras. Most importantly, they installed terrain-following radar. This helped pilots avoid flying into the ground during extremely low-altitude missions. Plus, to give the crew some defensive capability, the aircraft were heavily armed. Under the wings, they slung gun pods packing serious firepower. These were 7.62 mm 6-barrel GAU-2B miniguns. Each held 1,500 rounds. On top of that, the crew carried window-mounted machine guns and illumination flares for night missions. Given the unique nature of jungle warfare, these aircraft were painted in a green camouflage scheme. This was highly unusual for American naval aviation. The Neptune's incredible potential allowed Lockheed's engineers to constantly improve upon the design. On October 18, 1952, the sixth variant took to the skies for the first time. This was the P-2 V6, which arguably became the most versatile aircraft in the entire lineup. Aside from its primary role of hunting enemy submarines, this aircraft had many other uses. It could lay naval mines, carry out conventional bombing runs, take detailed reconnaissance photographs, and even launch precision-guided missiles. Thanks to new enlarged wingtip tanks, the total fuel capacity on this variant jumped to over 4,200 gallons. This significantly boosted its range. Engineers also expanded the weapons bay to accommodate an even wider variety of ordnance. On early airframes, an automated gun turret with a complex fire control system was mounted in the nose, but they eventually ditched it, turning the empty space into a spacious and comfortable workstation for the navigator. 16 aircraft from this Dash 6 series were turned into dedicated anti-ship platforms, armed with powerful petrol-guided missiles capable of hitting targets up to 22 nautical miles away. A few more airframes were adapted for launching high-speed aerial target drones or fitted with dual controls to serve as dedicated trainers. The aircraft's evolution continued. On April 26, 1954, the first of 3 pre-production prototypes for the all-new 7th variant took to the air. This was the YP-2V7. This test prototype still featured a dorsal turret armed with twin 50 cal machine guns. However, this turret didn't make it into full-rate production. Designers decided to remove it to save weight. This allowed for a much more important addition, which was a brand new sonobuoy-based submarine detection system. Visually, the Dash 7 was easy to tell apart from all previous variants thanks to its raised bubble canopy. The pilot seats were repositioned higher up, giving the flight crew a phenomenal field of view. On top of that, the wingtip fuel tanks were made slimmer and more aerodynamic. This was done even though it meant slightly reducing their overall fuel capacity. A mixed power plant became standard for this variant. The aircraft was equipped with 2 reliable radial engines plus 2 auxiliary turbojets. This powerful combination allowed the massive aircraft to reach speeds of over 400 miles per hour. The maximum takeoff weight of the airplane increased significantly, maxing out at 73,100 pounds. Because of this substantial weight, the maximum flight altitude dropped slightly to almost 22,000 feet. Since the new wing tanks were smaller, engineers had to find a way to maintain the flight range. The solution was simple. If needed, an extra tank holding almost 700 gallons of fuel could be installed right inside the bomb bay. As for armament, this giant could carry an entire arsenal with a total payload of 8,000 pounds. This deadly payload included naval mines and torpedoes. It also carried 16 5-inch unguided rockets, as well as conventional bombs and depth charges. But here's the most impressive part. The aircraft could even carry tactical atomic weapons. These included the Mark 90 Betty and the Mark 101 Lulu depth charges. This made it a truly devastating weapon for its time. With the introduction of the Mark 57 atomic depth charge into the Navy's arsenal, The P-2 V-7 aircraft was also modified to carry it. 7 specially modified P-2 V-7 aircraft were built for the United States Air Force. They received the new designation RB-69A. Interestingly, one of these airplanes was deployed to West Germany in 1958. It operated out of Wiesbaden Air Base. On some aircraft, the wingtip fuel tanks were removed. However, the hardpoints for unguided rockets were kept. The main mission for these airplanes was deep signals and electronic intelligence. For this, they were equipped with SLAR, or side-looking airborne radar. The antenna for this radar was hidden under a special fairing on the right side of the fuselage. It was located right between the wing and the tail section. Under the tail, sensitive receiver antennas were installed to pick up enemy radio emissions. In 1962, the United States military decided to standardize its aircraft nomenclature. They introduced a unified designation system for all branches of the armed forces. As a result of this massive reform, the Neptune aircraft received a new, much shorter designation. It was known as the P-2. It was under this very name that they went to war. They took an active part in intense combat operations in the skies over Vietnam. In 1967, right on the flight line, a few of these aircraft were modified into true flying gunships. Several multi-barrel miniguns were mounted at various angles in the bomb bay. Later, a 40mm grenade launcher was added. Thanks to this setup, the aircraft could lay down an absolute wall of lead. It easily shredded everything in its path. On top of that, on external hardpoints, the aircraft could carry 2 powerful Mark 82 500-pound high explosive bombs. It also carried 2 Mark 77 incendiary bombs. The basic design of the airplane underwent significant changes. The magnetic anomaly detector was removed to make room for a new tail turret. It was equipped with a Mark 8 sight and a special starlight scope periscope for night vision. The old APS-20 search radar was also removed. It was replaced by the more modern APQ-92 surveillance radar. The Special Ground Attack AP-2H variant received a major upgrade from Grumman. The aircraft was fitted with the Advanced Trim Multi-Sensor Reconnaissance Suite. This system featured television and infrared cameras to track enemy troops and vehicles from the air. This allowed the crew to find targets completely invisible to conventional radar or the naked eye. This made the aircraft a highly effective hunter during interdiction missions. The forward-looking infrared, or FLIR, and the ultra-sensitive low-light level TV camera were housed in a special pod under the nose. This camera could see perfectly even in pitch-black conditions. Crews commonly referred to this as the chin pod. Another standout feature was the ASD-5 Black Crow system. It could pick up the electrical emissions from enemy vehicle ignitions hidden deep in the jungle. Meanwhile, the MTI radar helped track moving targets. In 1970, Lockheed engineers turned one of the Neptunes into a flying testbed designated as the NP-2H. Its main job was testing the latest electro-optical systems. A special stabilized platform was mounted under the nose. It was packed with multiple sensors, all bore-sighted to a single focal point. A complex system of mirrors and a movable gimbal ensured that the image on the operator's screen stayed perfectly level and sharp. This worked regardless of turbulence or how hard the aircraft was maneuvering. The production run of the legendary P-2 V-7 came to an end in April 1962. This happened when the 348th and final aircraft rolled off the assembly line. Operating under the Military Assistance Program, the United States began large-scale deliveries of the aircraft to its allies. The Neptune quickly became the backbone of maritime patrol aviation across the globe. The British Royal Air Force also acquired 52 of these aircraft. However, after just a few years of less than stellar service, the British returned some airframes to the US and sold 8 directly to Argentina. The irony here is that 23 years later, those exact same aircraft would see actual combat during the Falklands War, flying against none other than the British themselves. If you look closely at the history of military aviation, you will notice an interesting trend. Combat aircraft rarely fight in the exact wars they were originally designed for. That is exactly what happened with the Neptune. Developed during World War II, it never actually saw combat in that conflict. Instead, it went on to become an icon of the Cold War era. Later, it became an active participant in countless regional conflicts around the globe. Following the end of the Chinese Civil War, the nationalist government relocated to Taiwan in 1949. To prevent a surprise amphibious assault by communist forces, the United States 7th Fleet deployed squadrons of Neptunes to bases in Japan and the Philippines. Their main mission was round-the-clock patrolling of the Taiwan Strait. This exhausting reconnaissance work lasted for several years and essentially deterred a full-scale war. The next major trial by fire for the Neptunes was the brutal war on the Korean Peninsula. Several U.S. Navy patrol squadrons flew deep reconnaissance missions against enemy targets along the coastline, spotted for heavy naval gunfire, and occasionally flew bombing runs themselves. Despite the high operational tempo, losses were surprisingly minimal, with only 2 Neptunes permanently lost during the entire Korean campaign. Meanwhile, the Cold War demanded constant surveillance of the adversary's forces. The Americans threw their Neptunes into the fray, probing for weak spots in the Soviet air defense network and gathering intelligence on classified coastal facilities. Naturally, these daring sorties did not always end well. Throughout the 1950s, several Neptunes were intercepted, damaged, or shot down by Soviet fighters over the Sea of Japan and the Bering Strait. The world faced a real test during the Cuban Missile Crisis in October 1962. This brought the globe to the brink of World War III, while U-2 spy planes first spotted the Soviet ballistic missiles, land-based P-2V patrol aircraft, along with carrier-based planes, flew round-the-clock patrols right off the island. They closely monitored the dismantling of the launch pads and watched the nuclear-capable Soviet Ilyushin-28 bombers. In 1964, the United States military became fully embroiled in the grueling Vietnam War. The core of the Navy's land-based patrol aviation flew P-2s, P-3s, and P-5M Marlin flying boats. The main job for the Neptune crews was providing a solid anti-submarine screen to protect the major carrier task forces operating out in the South China Sea. They were also tasked with actively disrupting enemy shipping along the coast. A typical combat mission went something like this. The aircraft patrolled at an altitude of around 1,000 feet, staying roughly 20 nautical miles off the coastline. Whenever the pilots spotted something suspicious, they would descend rapidly in a steep spiral. During night operations, they would light up the unknown vessel with their massive onboard searchlight or drop illumination flares to positively identify the target. If they confirmed a threat, the patrol aircraft instantly transmitted the coordinates, guiding U.S. Navy strike aircraft or surface combatants to the target. During major military campaigns like Operation Market Time, Neptune crews flew over 1,000 sorties, helping maintain a complete blockade of the entire coastline and inland waterways of North Vietnam. With coastal waterways effectively choked off, tracking enemy movements overland became critical. In 1967, a dozen OP-2E aircraft were assigned to airdrop a massive network of acoustic and seismic ground sensors directly along the Ho Chi Minh Trail. Heavy anti-aircraft fire claimed 4 of these aircraft during those dangerous missions. The Neptunes were also heavily utilized for special operations. In 1966, Army Aviation acquired 6 RB-69 aircraft, modifying them for classified signals intelligence missions. Packed with cutting-edge electronic intelligence gear, these heavily modified aircraft flew unarmed missions over South Vietnam, scanning the radio spectrum to intercept enemy communications. A single sortie could last up to 8 straight hours, frequently under enemy ground fire. At the same time, specialized AP-2H gunships flew hundreds of combat sorties, relentlessly hunting enemy convoys and river traffic in the dense jungles of the Mekong Delta. The true swan song for the Neptune came during the Falklands War between Great Britain and Argentina in the spring of 1982. At the time, the Argentine Navy had a small detachment of SP-2H patrol aircraft. They heavily relied on them to hunt for British warships in the South Atlantic. On May 4th, one of these Neptune crews pulled off an incredible feat. Despite their outdated search radar constantly glitching, they managed to pick up surface targets, relay the coordinates, and successfully vector in a flight of Super Étendard strike fighters armed with Exocet missiles. The Argentines successfully struck and sank the state-of-the-art British destroyer, HMS Sheffield. These aging Neptunes were pushed to their absolute limits and suffered from severe airframe fatigue, finally standing down from combat operations in mid-May. In 1964, U.S. Navy patrol squadrons started receiving the brand new P-3A Orion aircraft. By 1970, the famous Neptune began its retirement process. Its distinctive and elegant silhouette was forever etched into the memories of thousands of Navy sailors and aviators, becoming one of the most recognizable symbols of the Cold War era. For 16 long years, this aircraft firmly held the world record for unrefueled flight distance, until it was finally beaten by a B-52 bomber in 1962. Altogether, this tireless aircraft served in the U.S. fleet for over 30 years. After its official retirement, several airframes were given a second life and converted into heavy aerial firefighters used to battle massive wildfires. Today, you can still see this steel god of the sea with your own eyes. One of them is on display at the Aviation Museum located next to the military boneyard at Davis-Monthan Air Force Base in Arizona. Another historic Neptune rests at the Argentine Naval Aviation Museum. As a kill mark commemorating that successful strike during the Falklands War, the silhouette of the sunken British destroyer is still painted on the aircraft's fuselage.